Okay, in this video we are going to study dependent and independent events. Here the definition of independent event we have, so we will understand the dependent event, what is it. If there are two events like A and B and the results of them, they are not affecting each other. The A is not affecting the B is not affecting A, so these events, they are called independent events. But if the results are affecting each other, then these are called dependent events. So for the dependent events, or for the conditional probability, also we said conditional probability, the formula, it was probability of, let's say, B known that A happened is, it was probability of B intersection A, it was, over probability of A. So when you get this formula here, A intersection B, it's going to be probability of A times probability of these two, we are going to multiply and we are going to get this formula. But in the independent events, there's no importance of A, so we can cancel this A here, and the formula becomes probability of A intersection B, which means probability of A and B, two independent events happens together. So we are going to multiply the probabilities of these independent events. So here we have example: a die is rolled and a coin is tossed. Find the probability that the die shows 5 and coin shows head. What does it mean? It means that there are two independent events here because they are not going to affect each other, and probability of the 5 shows 5 is not related with the tossing the coin, and here it's going to be 1/6 because there are 6 faces on the coin, on the dice. And we have one coin and we are going to toss the coin. And what is the probability of tossing the coin? What is the probability of head? If you ask, we are going to say 1/2 for that one. So here it says the die shows 5, and this is the important part, that's why we are using intersection here. Probability of 5 intersection probability of head, it's going to be, which is equal to probability of 5 times probability of head, it's going to be, and the result is going to be 1/6 times 1/2, which is equal to 1/12 is going to be. This is the answer of our question. Okay, now a pair of dice is rolled twice, so we are going to roll the dice twice, 2 times. So what is the probability that the numbers showing add up to 9? The sum is 9 each time. Yes, these are showing the sums of when you roll 2 dice. So here this is 2, it's going to be, this table, and we are looking for the 9s. So when you roll 2 dice, and what is the probability of getting 9? Probability of getting 9 for the first time, it's going to be equal to 4/36, not 9, 4/36, because there are 36 numbers here, and we are looking for only 4 of them. 9 we are looking for, which is equal to 1/9. And you're going to get the dice in your hand and you're going to roll them for the second time. So these two actions is not going to affect each other. That's why we are going to do the same operation again. How many numbers there are, which are 9? Totally 4 numbers. How many there are in the set? 36. So the probability of second one, 36. And 4/36 is going to be. What is the 4/36? When you simplify, it's going to be 1/9. So for the first time 9, and for the second time 9, probability of 9 for the first time, and intersection probability of 9 for the second time is going to be 1/, or probability of probability of 9 for the first time, and times probability of 9 for the second time is going to be. Okay, what is the probability of 9? We found here it's equal to 1 over 9. Here it's going to be equal to 1 over 9 again. The answer is 1 over 81 going to be. Okay. Here there are 6 men and 7 women. Apply the 4 position of manager and assistant and manager in a company. Each name is written on a card and the cards are put in a box, all put in a box. Then 2 names are selected in succession. From the box at random without replacement, this part is important, without replacement, what is the probability that both of the people selected are men? So these are normally, these 3 events, they are dependent events. So we cannot use directly the previous formula, because let me explain. These are probability of A intersection B, okay, which is probability of A times probability of B, known that the first one is A. Okay, if you remember the formula, it was like that. Okay, so we are going to do with respect to this formula. Here, in the previous page, we're directly multiplying, because these are independent events, but these are dependent events. And what is the probability of A? What is the case A? Let's write first that one. Case A, the first man who is selected, he is going to be man. Yes. Probability of A is probability of A. There are totally 6 men and 7 women. That's why 6 over totally there are 13 people. And probability of B, the second case, again we want men, but we know that the first one is man. So if the first one is man, it means that there are 5 persons left and there are 12 persons left again. So the probability of A times probability of B, known that A is equal to 6 over 13 times 5 over 12 is going to be. And this is 6 and 12. If we simplify, this is going to be 1, this is going to be 2, 2 times 13, 26, and 5 times 1 is going to be 5, so 5 over 26 is going to be our answer. Okay, let's see the next one. Here, 3 balls are drawn successively without replacement from the box. This without replacement word, it's important. Which contains 5 red, 6 yellow, and 4 green balls. What is the probability that all 3 balls are red? As you see, these are again dependent events to each other. Why it is dependent? Because we are not going to put the one ball back again. So probability of the first event, let's say the selecting the first ball, ball 1. Ball 1 is we are looking for red, so it's going to be equal to 5 over there are totally 5 plus 6 plus 4, 15 balls. 5 over 15 is going to be. And probability of the second ball. Now we know that the first one is red. That's why we are going to select from 4 balls we are going to select from 13 balls we are going to 14 balls for them. From 14 balls we are going to select 4 of them. And again, probability of the third ball. Now we select 2 red balls and we have maximum 3 red balls, and from the total set without replacement inside, we are not going to put them, so 15, 14, then 13 left. And what is the probability of ball 1 is red, ball 2 is red, and ball 3 is red? When you ask, we are going to find the 5/15 times 4/14 times 3/13 is going to be our answer. 5 and 15, if you simplify, 1 and 3, it's going to be 3 and 3. If you simplify, it's going to be 1 and 1, 4 and 14, 2 and 7. So the answer is 3 times 10 is equal, 7 times 10 is equal to 70. 7 times 3, 21. 71 plus 21 is going to be 91. This is the denominator, and the up is 2 is going to be. Okay.